Hello everyone. I want to explain about forward kinematics of two-planar robot using MATLAB. My name is Nugroho Putuwijasono and this is my homework for number 1. As we know, forward kinematic involves determining the position and orientation of robots and effector, which is the component that interact with the environment, like a gripper or tool, like a screwdriver, like that, and any other sensor. This pose is measured relative to a fixed reference frame, typically the robot base. To carry out FK or forward kinematics, we need to know the robot joint angles, link lengths, and the trigonometric and algebraic relationship between them. And there is also inverse kinematics, a limitation from forward kinematic that it does not tell us how to move the robot to achieve a desired pose or desired position for the n effector. And for that, we need to use inverse kinematics or IK, which is the opposite of forward kinematics. The calculation for inverse kinematic is more challenging and complex because it's involve multiple solution or maybe numerical errors. And in this video, I only cover the forward kinematics formula. Forward kinematics. This is the two planar robots. We have this one. This is represent the joints. This is the joint. There is two joints. This is joint 1. This is the link 1. And this is the joint 2. This is the link 2. L1 represent the unit of the length of the link 1 and L2 represent the unit of length from the link 2. Theta represent the angles of from the base. This is the usually X is considered as a common reference. So this is from the X to the theta is the degree of the angles of from the link 1 to the reference. And phi this is the angle from the link 1. So this is the link 1 right now is become the x1 is the reference from the x1 to the angles of L2. So basically when we want to measure the the angles from L2 to the reference of X, so we need to add theta to phi like that. So to know the position of x1, this is the x1, and this is the y1, we need to calculate the using the trigonometry. We can calculate the x1 is equal to L1, the L1 multiplied by cosine of theta. And for the y1, we need to multiply the L1 sinus sine theta. And this is the complete formula uh, to find the value of x2 and y2. Theta is the joint angle from joint 1 to joint 2. Phi is joint angle from the joint 2 to the n effector. So this is considered as the n effector. So this is the result. If I simulate this in the MATLAB, this is the location of its joint. This is the n effector. If the q are the angles, this is the theta. If the theta is pi over 4 divided by 4, and if the phi is pi divided by 3. This is in radians. And for the second question, the hue defined as an array of theta and phi. The theta is minus 1 radians and the phi is 2. So we simulate using MATLAB. Let me clear it first. Clear and so when I want to put Q, this is the Q. Okay, let me change the preferences like this. So this is the code, function code, and let me clear this one. Uh, the first question is if the theta is pi divided by 4 and the phi angles is pi divided by 3. We know this is the value, and then we will call the forward kinematics on Q, and this is the answer. So this is the base 0. The base 0, x is 0, y is 0. This is the first joint. The position of first joint is 0 by 0, and this is the second joint. The position is 5.65685, and for the y is same with x. This is the position, and then for the n effector we have this position. Okay, and then if we change that the q is the theta is -1 and -1 radian, and then for the phi is 2 radians. We calculate that, and then we got this. This is the first one, and this is the second one. This is the 0 0, and this one is the position of from the link one. We got 4 0.32242 and then for y we got minus 6.73177, and on the n effector we got this position. For the x is 9.18514, and for the y position is 0.841471. Okay, that is the end of my presentation. Thank you so much for your kind attention, and see you on the next video.